Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which prints post-order traversal from given in-order and pre-order traversals. First, let us take an example. As you can see, we take in-order and pre-order traversal as input from the user and output the post-order traversal. Now, let us have a look at the algorithm which will assist us in this. We have the sample in order and pre-order arrays and we pass them to function print post order along with the size of the array. Now, the first element in the pre-order array is root. So, we search for it in the in order array to find the left and right subtrees. So we call the search function with the in-order array, the first element of the pre-order array and n. We run a simple for loop for searching the element in the in-order array. Since 1 is at position 3 in the array, we return 3 and hence root will point to 3. Since root is not equal to 0, we call the print post order function with in-order array pre plus 1 and root. We again call the search function with first element of pre-order array and n. Since element 2 is at position 1, we return 1. As root is not 0, we call the print post order function with in-order array pre plus 1 and root. Again, we call the search function and find for the first element in pre-order array in in-order array. Since 4 is at position 0 in the in-order array, root will be equal to 0. As root is 0, we check if right subtree is not empty. Since root is equal to n minus 1, we omit the if statement and print the first element in the pre-order array. Hence, 4 is printed. We finish execution for the last call. Now, we go to the second if and check if root is not equal to n minus 1. As it is true, we call the print post order function with in plus root plus 1, pre plus root plus 1 and n minus root minus 1. Now we call the search function with in order array 5 and n, which is 1. Since 5 is at position 0 in both the arrays, the value returned will be 0. Since root is 0 and also it is n minus 1, so we print the element at 0th position in the pre-array. Hence 5 is printed. Execution for the previous call is resumed. Now we go to the cout part and we print the element at the 0th position in pre-order array. So 2 is printed. We go to the previous call. Now we move on to the second if statement in the print post order function. Since root is not equal to n minus 1, we call the print post order function with in plus root plus 1, pre plus root plus 1 and n minus root minus 1. We call the search function and since 3 is at position 0 in both the arrays, root will be equal to 0. Since root is not equal to n minus 1, we call the print post order function with in plus root plus 1, pre plus root plus 1 and n minus root minus 1. As there is only one element in both the arrays, root will point to 0. As root is 0 and root is n minus 1, we print the element at 0th index in the pre-array. So 6 is printed. Execution for this call is over. Now we go to the print part and print the element at 0th position in the pre-array. Hence 3 is printed. Also, execution for this call is over. Finally, we print the element at 0th index of pre-array. hence 1 is printed. We have the final post-order traversal. With this, we finish execution of this program. Now, let us have a look at the time complexity of the program. This code will run in big O of n square complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.